We're starting here with a piecewise function, and what they want us to do with this piecewise function is find the a and the b value that make this function differentiable at x equals 3. In order to make something differentiable, we first have to remember what differentiable means. So differentiable is a definition you gotta have down when you go to take this test. My little short saying that I use when I do this is I know that the graph needs to have two properties at that point. It needs to be smooth at x equals 3, and the other thing it needs to be is continuous. So it has to be both smooth and continuous. Smooth meaning no sharp corners, no cusps, no verticals, anything like that would be a place where it's not smooth. To show that something's not smooth, you essentially need to show that your left-hand derivative, your LHD, left-hand derivative, is equal to your right-hand derivative, RHD, at x equals 3. Then, to show that it's continuous, what you would need to do is you need to know the definition of continuity. So the definition of something being continuous says the limit as x approaches 3 at that value has to equal f of 3. So my overall limit has to equal the dot on the graph. I start this process by always going through the continuity piece first. So the first thing I want to do is use the fact that I know if this is going to happen, these two things need to be continuous. So I need to show that the limit as x approaches 3 of f of x equals f of 3. When you're dealing with a piecewise function, really that boils down to making sure your top equation and your bottom equation intersect, run into each other at the points you care about, right? A piecewise function could have a jump in it because it's two pieces of two different graphs. And what we need to make sure is happening on ours is we need to make sure that that left-hand equation and that right-hand equation are coming together at the same place at x equals 3. To do this, you're just going to set those two equations equal to each other, because if they're equal to each other at that point, that means they ran into each other at that point. So you want to take your top equation and set it equal to the bottom equation. So I take the top equation, ax plus b, and I set that equal to the bottom equation. So that's going to be x squared minus ax. And then I know those things have to be equal when x equals 3. And so I'm just going to take now and I'm going to plug 3 into both of them wherever I see an x. So this would be a times 3 plus b equals 3 squared minus a times 3. And then simplifying that down, you get 3a plus b equals 9 minus 3a. So we still aren't as far as we need to be because right now we still have two variables and we can't solve for one. But that's where you wanted to start. Then the next move is come over and you need to show that these things are smooth. And to show that they're smooth at that point means my left-hand derivative has to equal my right-hand derivative. And so again, what I'm going to do is I'm basically going to have a top derivative, and I'm going to set that equal to the bottom derivative, and make sure that when I plug in x equals 3 for both of them, that they equal each other. So again, looking at the top equation, that would be ax plus b. Looking at the bottom equation, that would be x squared minus ax. I now need to find their derivatives. So taking the derivative of this first equation, remember a and b are numbers. It's just like having 3x plus 7 right now. That's kind of the derivative you want to have in your mind. So a and b are numbers right now. So the same thing you would do to that 3x, you would do to the ax. So the derivative of ax is just going to be a. The derivative of b, that's a constant, so that goes to 0. Going on to the other side, the derivative of x squared is 2x. And then again, this is like having minus 3x right there. So the a sticks around and that x goes away. Now what we can do is we can plug in for x what x is to this equation because those two things have to be equal at x equals 3. So a is going to equal 2, and then I plug in 3 for x and then minus a. Because I have only one variable now, I can go ahead and solve this equation for that one variable. So I'm going to be able to get my a value that I'm looking for. So I add a to both sides. I get 2a equals 2 times 3 is 6. And then from there, I would go ahead and divide by 2, and I end up with a equals 3. So I now have my a value, but I still need my b value. Conveniently, that's where that continuity equation comes in. I can now plug in a as 3, because I know that's what it equals, into this equation, and I'm going to end up getting an equation that's talking just b's that I can solve for. So this would be 3, and then instead of a, I'm plugging in 3, plus b has to equal 9 minus 3, and then again, I'm plugging in 3 here. And now we just need to clean this little math problem up. So 3 times 3 is 9 plus b, and on this side we end up with 9 minus 9 is going to be 0. And now you're just trying to solve for b, so last little move here, get b by itself, minus that 9 over to the other side, and you get b equals negative 9. To make sure that you don't work backwards from the answers, oftentimes what they like to do is ask you to perform a little extra move, right? So this time they want us to know, what does a plus b equal? That'll be our final answer. So we take our a value, which is 3, we add to it our b value, which is negative 9, and so out of there we end up getting out 6. And so our final answer on this problem would be 6. Oops, no it wouldn't be. 3 plus negative 9 is negative 6. Got to be careful there. Math going too quickly. Not 6, but negative 6. Always check your signs. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.